Have you ever wondered if the choices you make are truly your own? Or are we simply cogs in a giant pre-programmed machine, our destinies already written in the fabric of the cosmos? This is the fundamental question at the heart of the debate about free will versus determinism. Determinism, a concept deeply rooted in classical physics, posits that everything in the universe is predetermined. Think of the universe as a giant clock. Every tick and tock, every movement of its gears, is a consequence of the previous state of the clock. Similarly, determinism suggests that the universe, governed by immutable physical laws, unfolds in a predictable and inevitable manner. From the largest galaxy to the smallest atom, everything dances to a predetermined tune. This idea is deeply unsettling to some. If our choices are merely consequences of prior events, what does that say about our sense of agency, our belief that we are the masters of our own fate? Do we have any control over our lives, or are we just along for the ride, our paths already laid out before us by the ironclad laws of physics? Now let's delve deeper into this deterministic view of the universe. Imagine, if you will, a hypothetical being with infinite intelligence and knowledge, Laplace's demon. This all-knowing entity, conceived by the French mathematician Pierre-Simon Laplace, possesses complete knowledge of the universe's current state. Armed with this knowledge and the unchanging laws of classical physics, particularly Newtonian mechanics, Laplace's demon can, in theory, predict the future with absolute certainty. Every event, from the fall of an empire to the flutter of a butterfly's wings, becomes knowable, predictable, and inevitable. This thought experiment brilliantly illustrates the implications of hard determinism. If the universe operates like a giant, perfectly predictable machine, then free will, as we commonly understand it, might be a mere illusion. Our choices, desires, and aspirations would be nothing more than predetermined outcomes of the universe's initial conditions and the laws that govern it. But wait, there's more to the story. As we delve further into the mysteries of the cosmos, we encounter Albert Einstein's groundbreaking theory of relativity. Relativity challenges our intuitive understanding of time, suggesting that it's not absolute but rather relative to the observer's frame of reference. Imagine two people, one standing still, and the other traveling at near the speed of light. Time would pass differently for both individuals. The one traveling at high speed would experience time dilation, where time slows down relative to the stationary observer. This mind-bending concept suggests that our perception of time as a linear, forward-flowing entity might be an illusion. This leads us to the block universe theory, which proposes that the past, present, and future all exist simultaneously within the fabric of space-time. Imagine a loaf of bread where each slice represents a moment in time. The entire loaf, all moments coexisting, is the block universe. This perspective challenges the notion of free will even further. If all moments already exist, are our choices truly free, or are they just points along a predetermined path in this static, unchanging block? Section 4. Quantum Mechanics. Introducing uncertainty into the equation. Just when we thought we had a handle on the deterministic universe, quantum mechanics, the study of the very small, throws a wrench into the works. Unlike the predictable, clockwork universe of classical physics, the quantum realm is inherently uncertain. The Heisenberg uncertainty principle, a cornerstone of quantum mechanics, states that we cannot simultaneously know both the position and momentum of a particle with perfect accuracy. The more precisely we know one, the less we know about the other. This inherent uncertainty isn't due to limitations in our measuring tools, but rather a fundamental property of the quantum world. This inherent randomness at the quantum level challenges the deterministic view of the universe. If the building blocks of reality behave unpredictably, can we truly say that everything is predetermined? Could this quantum indeterminacy be the source of true randomness in the universe, potentially leaving room for free will to operate? Section 5. The Many Worlds Interpretation, a Universe of Infinite Choices. Let's dive deeper into the rabbit hole of quantum mechanics. One fascinating interpretation of quantum uncertainty is the many worlds interpretation. This mind-boggling theory proposes that every quantum measurement, every interaction at the subatomic level, causes the universe to split into multiple parallel universes, each representing a different outcome. Imagine, for instance, that you're faced with a choice to eat an apple or a banana. In one universe you choose the apple, while in another you opt for the banana. Each choice creates a new branch of reality, a parallel universe where that outcome unfolds. The many worlds interpretation suggests that all possible outcomes of every quantum event are realized in some parallel universe. If this interpretation holds true, it paints a fascinating, albeit dizzying, picture of reality. Our lives become an exploration of countless parallel universes, each representing a different path we could have taken. This perspective reintroduces the concept of choice, although in a dramatically different light. We may not have free will in the traditional sense, but our choices could determine which branch of reality we experience. Section 6. The brain, a biological machine making choices for us. Now let's shift our focus from the vastness of the cosmos to the intricacies of the human brain. Neuroscience, the study of the brain and nervous system, offers intriguing insights into the biological basis of decision-making. Some neuroscientific studies suggest that our brains might be making decisions before we're even consciously aware of them. For example, experiments using brain imaging techniques such as fMRI have shown that certain brain regions display activity related to a decision moments before a person consciously reports making that decision. This raises the question, if our brains are already making choices before we're consciously aware of them, how much control do we truly have over our decisions? Of course, correlation doesn't equal causation. Just because there's neural activity before a conscious decision doesn't necessarily mean free will is an illusion. It could be that our conscious awareness simply lags behind the unconscious processes already underway in the brain. Nevertheless, these findings raise fascinating questions about the nature of consciousness and the extent to which we truly control our thoughts and actions. Section 7. Free will or illusion? A question that continues to puzzle. So, where does this leave us in the grand debate about free will? We've journeyed from the deterministic clockwork universe of classical physics to the mind-bending realms of quantum mechanics and the mysteries of the human brain. We've encountered thought-provoking concepts like Laplace's demon, the block universe, the many worlds interpretation, and pre-conscious decision-making. The question remains, do we have free will or is it all an elaborate illusion, a trick of our consciousness? The answer, my friends, is far from simple. The universe continues to reveal its secrets to us, and with each discovery, new questions arise. Perhaps free will exists, not in absolute terms but rather as a spectrum, influenced by a complex interplay of deterministic factors and quantum randomness. As we delve deeper into the mysteries of the cosmos and the human mind, we must remain open to new possibilities, embracing the wonder and uncertainty that comes with exploring the universe's greatest enigmas. Ultimately, the question of free will challenges us to think critically about the nature of reality, consciousness, and our place in the grand scheme of things. A question that will likely continue to fascinate and perplex us for generations to come.